Hello everyone. Today we will be creating a clock using four of these 7 segment displays. Let us just do a revision of whatever we did in the previous session where we created a display of three of these displays. Uh, we know that all these displays are actually connected in parallel, so that means the B segment of one is connected to B segment of the second one, is connected to the B segment of the first one, and so on and so forth. So that means all three of them are connected in parallel, and the common cathode, these are all common cathodes. So the common cathode of each is connected through a resistance to one of the pins, that is pin number 9, 10, and 11. These are basically controlling the three blocks. And if the block is getting uh, a high on these, this will not display, otherwise it will display. This is the final simulation of that I showed you. This is in slow motion. This is what is actually happening. So that means all three digits are being displayed, but they are being displayed one after the other. And when we do it fast enough, uh, they will be do, uh, they will be displayed together. Let's do it fast enough. So that means we have actually done it after a difference of 500 milliseconds. So I'll change it to just 10 milliseconds. So let us see. Change this to 10 milliseconds and change this also to 10 milliseconds. And let us now see the simulation. And when you see the simulation, you see all the three numbers displayed together. So you can figure out yourself now that these are not displaying together. They are displaying one after the other, but they are the thing is happening so fast that our eyes cannot basically figure out that one is actually switching off, the other is switching on, and so on and so forth. Let us now go to our new design now. This is the clock that I was talking to you about. So this is the clock that I have created. Uh, you can see that this is exactly the same as the previous one. I've just added one more here, and all four of them are actually connected in parallel. So you can see A, B, C, D, E, F, G. All the segments are connected in parallel. So, like for example, this is a G. So this G is actually connected to the G of the second one. This is connected to the G of the third one. This is connected to the G of the fourth one, and so on and so forth. So all 7 segments are connected together. So that is not a problem. But the common cathodes are connected through a resistance to four pins 9, 10, 11, and 12. And okay, so this is the circuit. All right, so this is the basic circuit. Let me show you the simulation first, and then you can go ahead. The simulation starts at 29:55, like 29 minutes 55 seconds, and it is now showing 30 minutes. You can see that all four of them have changed according to the seconds. All right. All right. So this basic circuit remains the same. Our coding will be different now. So let us see the coding. What changes have I have done? This is exactly the same as the previous one, so there's no problem. What about these ones? Yes, these would be different. I'm using 4 blocks, so I'm using B1, B2, B3, B4, which are connected to 9, 10, 11, and 12. So I'm using B1, B2, B3, B4 as names for the 4 blocks now. So long TM is the time in seconds. Why I have used long, you know that basically we did in the clock program that we did with LCD. Alright, these are the milliseconds. We'll talk about milliseconds in a little bit of time now. Alright, uh, we have created a function called display function here. Right, so those students who actually know about functions, a function basically is a name given to a set of statements which is performing one complete task or a subtask. So what task is it actually performing? It is actually getting two things from wherever it has been called from. So this is where the call has come from. So for example, whatever is the value of b1 actually will be passed to b, and whatever is the passed value of n1 will be passed to c. So whatever the values are. So b1 is suppose 9, so b will be 9. n1 is 2, this will be 2. So what is it actually going to do now? This is going to digital write b comma low. So when this is low, whatever we have actually called from, so b1 block will be active now. All right, because it is low, and it is going to display the digit, whatever digit we are talking about here. It will give a delay of 10 milliseconds, and then it will switch off this block. So because this thing is going to be repeated again and again, so why write this block of code again and again? We created a function for it, and I made 4 calls from here. So each call is actually going to activate a block, display the number, and then deactivate the block. Again, it will activate the third one, and so on and so forth. Again, activate the fourth one, and so on and so forth. All right. What else did I do? So, in fact, this was the function that we actually used. So, whenever we use a function in C++, we need to in the beginning we need to display write down the prototype of that particular function. Okay. So the prototype is exactly the same, has the same header as the function itself. All right. So you can name these differently. I can say block and I can say number. Okay, so that doesn't matter, but it should have the same data types and the name of the function. What else did we do? I'm starting my clock at 29 minutes and 52 seconds, and this is the time in seconds. Um, we have done this calculation before. So minutes multiplied by 60 becomes seconds plus SC. It gives me the total seconds. So 29 to 60, whatever it is, plus 52. In modes we have done earlier. All right. Now TM I have used as the time in seconds, but the time in seconds should be actually converted back to minutes in seconds, because it is easier to just increase the time. I have increased time here. So when I increase time, I don't need to worry about, if I'm only using seconds, I don't have to worry about the hours and minutes and so on and so forth. I'm just increasing seconds, and this part of the program will actually convert that seconds into minutes and seconds. Okay, so this code already we have done, so you can figure it out. Now I have created 4 numbers here, n1, n2, n3, n4, and all the n1, n2, n3, 4, n4 are actually going to be corresponding with each of these digits. So the first block is actually n1, the second is n2, the third is n3, the fourth is n4. All right. So you know that n1, n2 are actually going to be minutes, and n2, n3, n4 are going to be seconds. Now n1 has 2 digits. Sorry, the minutes has two digits like n1 and n2. And you also know that if minutes is actually a single digit number, the first one should actually display 0. So we have made sure we do that. So we have given an if condition. If minutes is less than 10, then n1 is 0 and n2 is minutes. And else, suppose it is a 26, I need to segregate them as 2 and 6. So how do I do that? We have calculated as minutes divided by 10. So minutes like 26 divided by 10 will give me a 2. So n1 is going to be a 2. And n2 is equal to 26% 10. So it will give me the remainder. The remainder is a 6. So n2 will be 6. Okay, so we have just taken that example now. Similarly for seconds. Seconds also is because when it is a single digit number, the first digit is a 0. Alright, so this is actually replicated. The whole thing is the same as minutes. In minutes and seconds, it's exactly the same. Now, after this thing happens, we give 4 display calls one after the other. So one after the other, so this happens very fast. So display b1 comma n1. So that means n1, whatever is has been calculated here, here or here with whatever, that will actually be displayed in the first digit, in the first block. All right. Whatever is n2, that will be displayed in the second block. Whatever is n3 in the third block. Whatever is n4 in the fourth block. Now ml is actually my milliseconds. Now please remember, um, how do I figure out 1 second is over? I cannot say 1000. Why? Because actually each of these blocks is actually using up 10 of those milliseconds. 10, 10, 10, 10. So this is 40 milliseconds have been used by these four blocks. So if 40 of these have been used by these blocks, uh, how many times do you think this whole thing is actually going to happen in a second? So 1 second is 1000 milliseconds. So 1000 divided by 40 is 25. So the moment I am actually counting my ml over here, so the moment ml becomes divisible by 25, I increase the time by 1 second. So this should be very, very clear to you. All right. So first thing to do is calculate the time in seconds. Then, uh, then separate those seconds into uh, minutes and seconds. Then find out what is going to be displayed in the four blocks. So N1, N2 is basically concerned with minutes, and N3 and 4 are basically concerned with seconds. After that is done, display each one of them, and it'll actually call this, and there will be a delay of 10 milliseconds. So 40 milliseconds delay in all these four. So 1000 divided by 40 is actually 25. So actually, when this whole loop actually has worked 25 times, we should increase this number of seconds. The seconds. So we increase ml plus plus, we increase it by 1. And the moment ml becomes divisible by 25, so that means whenever I divide it by 25 and the remainder is a 0, I increase tm, which will now be used to figure out what is the new second now, because tm is now going to change. Now you saw in the program how this happened. Okay, so it started with 52, 53, 54, 55, 56. So 7, 8, 9, and 0. So this has become a 0. So this whole thing is basically controlled by TM. All right, all these four blocks are controlled by TM. How do we separate them into N1, N2, N3, N4? You have already done, and that's it. Okay. Now, I have created this clock with four of these blocks. As an assignment, you could try now creating it with six blocks. That means one, two blocks for hours also. So what are you going to do is that you're going to put two more blocks here. That means you are going to use two more 7 segment display blocks, and again copy the same, connect them in parallel, and use two more of these common gate nodes. Okay. Please remember, you will not find many digital pins available now. So that means one digital pin you can use pin number 13, and you can use pin number A0 for the 14th, for the one that is left out. Okay. So this means what? Um, an analog pin can be used to take input or output of digital also, but it is not the same case with digital. Digital is never, always cannot be used for digital input and analog input and output. So that means for the fifth and sixth blocks, you are going to use pin number 13 and pin number 0 maybe. All right. All right. I hope you have understood whatever has been explained here. Um, if you have any problems, please write in the comment section. If you need any, if you want to give any suggestions For a future project, or maybe for something that you have not understood in any of the Arduino projects, then you could message me. And please do subscribe and like this video. Thank you so much. I'll see you in the next one.